Questions before we start. I want to talk about ODPs. I want to talk about more scanf and sscanf and fgets, and then I want to talk more about VI. Questions up front. Yeah.
I was having a weird error come up when I was trying to do the, I think it was the GCC main C pixie. That wouldn't work, but when I tried the next GCC, like the pixie temp one, that would compile it.
So what kind of error were you getting when you tried?
It said something about, like, I'm trying to remember the word, but it was saying something, it had something to do with, like, the function pick within the, I think, the main loop.
So you had a main program inside main.c?
In the test one, yeah.
Okay, and did it have a prototype for pick?
Yeah.
Okay. Do you know what the exact error was?
I don't remember.
Can you reproduce it?
I will try.
Okay, let me know.
Okay.
Yeah, so this is a tricky procedure the first few times, but it's something that we'll see a lot. What's happening here is if you make a main program called main.c, right, that's got a main program in it, and you've got your pick.c, with its stuff. So you compile this. If you do gcc-c, you got a pick.o. All it's got inside is this pick function. If you were to do gcc-c on main, you get a main.o that just has your main function. When you do this, right, it's compiling this to make what we call an object that contains pick, compiling this to make an object that contains main, and it's putting them together. Now somewhere in here you're calling pick, right, and the compiler will generate code to say, okay, jump down to, you know, wherever I decided to put this thing in memory. Before you can do that, somewhere in your main program you need to prototype pick. So you say integer pick parentheses integer. You can put an argument here or not, it's optional. But then a semicolon, right, to say this is not the definition of the actual code for pick. This is just telling you what pick looks like. Okay, yeah, and if you leave that off, then it gets confused because it's like, what's pick? I've never heard of that before.
So I did want to ask about with function prototypes. I've had a lot of experience in the past with writing C programs where it doesn't seem to care, like if I don't do a function prototype,
Right.
I'm fine with that.
Right.
But then sometimes it doesn't like that. So I was wondering if you know kind of like rules of thumb with
So,
okay with that.
yeah, so when I learned C, you never had to prototype functions, right? And it just kind of did the best it can. So my feeling, and I've never explored this, but my feeling is if your arguments are integers and your return type is an integer and you don't prototype, it seems to figure it out. But if you're going to pass anything else, it may make the wrong assumption. But definitely don't try to play that, right? Definitely prototype. So that's just building a test program, and then this down here, /temp/odp410 main.o, that's a different main.c that I wrote that I already compiled for you and put in that /temp directory. And then it's linking that with pick.c. So that's taking the place of main.c here. So /temp is just a directory, right? And if you go onto the Linux server, /tmp is just a directory. It contains a bunch of stuff. In particular, it contains the .o files for your next 3 ODPs. And And you can use the temp directory within reason. Right, so I just copied something into a file called zzz haha, and now if I look at /temp, there's a file in there that I created. Right, and we all have files in there that pop up when we log in, and different things use the temp area for different purposes. And it's not a totally free to use however you like kind of area, because you might put a file in there and somebody else might already have a file with that name. Plus it gets cleared out every time the system reboots. It's really meant for very short-term temporary storage. And I use it for ODP files. But so this is a file ODP 410 main.o that's just sitting in that /tmp directory. If you want, you can copy that file into your own directory. So copy from that file into dot. Dot means my current directory. And now in my home directory, I've got my own copy of ODP 410 main.o. There's no need for that, right? You don't have to have it in your directory, but if you wanted it for some reason, you can do that. All right, any other questions on that ODP? And the code was pretty straightforward. And I looked at people's code, and most of them did something pretty close to this, right? So take your argument, calculate it mod 4. If that's equal to 0, return 1. Otherwise, return the remainder of n mod 4. That's really all there is to the pick function. The real challenge was, linking it up and assessing it and all that kind of stuff. So it's kind of like a hello world for functions. So the next ODP, which is due tomorrow at 8. So this one goes a little deeper with scanf. So you're going to write a function called parse. It accepts a char star, that's a pointer to a character, that's a character array or a string, and it returns an integer. So you can declare your function as integer parse parentheses char star and whatever variable you want to use for that argument. And it's going to use scanf to try to convert that argument to an integer. Okay, so again, there's no fgets or gets or getchar or anything like that. You're just taking this argument to the function and feeding it through scanf to see if it's a valid integer. And if it's an integer and it's equal to 1, return 1. If it's 2, return 2. If it's 3, return 3. Otherwise, return -1. And don't print anything. Don't say your integer is not valid. I'm returning -1, because it won't assess. Okay, it's just a function. Take something in, return a value, either 1, 2, 3 or -1. Okay. So if the string is empty, if it starts with something that's not a digit, if it's an integer bigger than 3 or less than 1, if it has non-printable characters, if it's something like 1.2, which is a floating point number, in any of those cases you should return -1. If it's something like 0.0000002, scanf will turn that into an integer equal to 2, so you should return 2. So do not try to parse this yourself. Don't start looking at characters and say if this has got an ASCII code between this and that, and if it's followed by this. Don't go down that path, right, unless you are doing it deliberately as a challenge to see if you can replicate what scanf does. Okay, if you just want to do this and make it work, use scanf. So make your function called parse, put it in a file called parse.c, no main program in parse.c, test it as usual, make your own main program, and then when you're ready to assess, do it like this. And I put extra spaces in here. Right, so link your parse.c with the test bed and then assess parse.c. All right, is behavior clear? So let's dig deeper into scanf. I'm going to use command line argument. Well, okay, I want to talk about fgets anyway. Let's talk about fgets. You don't need to use this for this ODP. In fact, if you use this for this ODP, your ODP will not assess. But for PA2 and for a lot of other things and for writing test code, it's useful to be able to read input from the user while the program is running. Right? Something different from a command line argument. So something like when we say read in bash, the program waits for the user to type something in. The main way we do this in C is with fgets. So fgets takes 3 arguments. It takes some sort of array of characters, a string. It takes an integer, which is the length of the string, and then it takes standard in. So for example, we might say char str bracket 120. So fgets, we would say str comma 120 comma standard in. And this will say stop running the program, wait for the user to type something in, followed by the enter key. When they hit the enter key, up to 119 characters that they've typed will get stored in this string. It'll be null terminated, and fgets will return, it actually returns the address of this string. So let's just write some code like this. So I'm going to prompt the user by saying enter something. I'm not going to put a new line at the end. And I'm going to just use fgets, string 120 standard in. And then I'm going to print out what you typed in by using a %s in printf, and I'm just going to print str. Okay, something to note here. I'm saying you entered, and I'm printing out the string you entered with a %s. I'm putting angle brackets on either side. Why am I doing that? Because if the string ends with a bunch of spaces, and I just print out you entered value of str, you're not going to see those spaces. It's going to print them out, but they're white space. They're the color of the background. You're not going to see them. So I usually print strings inside some kind of delimiter set so that I can really clearly see if there's something in the beginning or something at the end that I might otherwise miss. I'm expecting it's going to say you entered less than sign, something, and then greater than sign. And everything between those two delimiters is the value of string. It's just a little trick that once in a while will save your skin, because there'll be a space at the end that you don't notice, and you'll pick it up like this. And it doesn't have to be angle brackets. It could be parentheses or quotation marks or anything you like. But it's just a useful thing when you're printing strings. So let's just run this code. So go enter something. I'll say hello. It says thank you, you entered hello. And here the angle brackets are doing something nice for us. They're letting us see that there's a new line after the O in hello. Right? There's no denying this, H-E-L-L-O, and then we went down to a new line, and then we printed that closing angle bracket. So fgets, when you read from standard in, you hit an enter at the end of it, that new line that's generated by hitting enter is part of the string. So strings you enter from here will automatically have a new line. If I just hit enter, without glitching, if I just hit enter, I don't get an empty string. I get a string with one character in it, which is this new line, this \n, followed by a null terminator. That's important to know when you're doing test cases, because if I'm trying to test something with an empty string, I can't generate an empty string using fgets. It'll always throw that new line on the end. So that's just something to keep in mind. So we have a string length function inside string.h. We can use that as another way to check the length of a string. And let's just sort of hammer the point home. I'm not going to worry about that. So if I say hello, it tells me the length of my string is 6. If I just hit enter, it tells me the length of my string is 1. So it's always sticking that new line on the end. Okay, have you talked about the function gets in CSE 121? Yeah.
So you didn't write return 0, it still worked.
Say again?
You didn't type return 0 in.
Oh yeah, I forgot my return 0.
But it still worked.
There we go. Yeah, it still worked. C is wonderful and terrifying at the same time because it will do exactly what you tell it to do, right? I told it to run and then just fall off the edge of the earth at the end of my code, and that's what it did. And it doesn't do any harm in general, but it's got an unpredictable return value if you don't actually say return 0. But I'm not using the return value. So, you know, most languages you've got to follow a set of rules, and if you don't follow all the rules, it gives you an error and it won't compile. C is very much like assembly language. It will do whatever you tell it to do. You can write almost complete nonsense, and it'll go ahead and do it. And that's a feature to me, not a bug, because you can get it to do all kinds of things that you know, other languages may not want you to do. So yeah, I try to put return 0 at the end. I usually forget because I know it's not necessary, but it's good practice. All right, have you talked about the gets function in 121?
You use gets and fgets as well.
Yeah, so gets is a version of fgets that basically just reads from standard in. And you just say gets and put in the name of a character array, and it's an easier function to use. So if you look at the manual page on gets, it says deprecated, and it says under description, never use this function. Okay, it's still in there for backwards compatibility, but definitely if you're in a job interview or programming interview or something, don't ever use the function gets. Okay, it's considered to be kind of a rookie thing to do. It exposes you to a potential buffer overrun. Now, if you're writing a piece of code on your laptop that you're going to run 5 times to try something out and you're using gets, it's not like the sun's going to collapse in on itself and we're all going to die. But if you put code out on the web where people can type something into your program and you're going to do something with it, even if your code is completely benign, it's just, you know, reading in a number and printing out the square root of it, right? If you read that number in with gets, there's a potential exploit that can be used. Because gets does not have any way of knowing if the person is typing in more stuff than the amount of space that you set aside to store it in. So with fgets, we have a string that holds 120 characters. We tell it you can only load 120 characters into there. And if the person types in 5,000 characters, the first 119 will get loaded in here, and then null terminated, and fgets will return. And the next time we call fgets, it will start with the next character that wasn't loaded, and it'll load that in. Gets doesn't have any way to do that. So if you type in 5 million characters, it will take all 5 million characters and store them at your string starting with the first character. After 120 characters, say you're at the end of your array, now you're working with some other variables that happen to be next in memory. That's where it's going to store the input. And so somebody who knows what your code is doing and knows how it's organized in memory can start changing the values of other variables by very carefully typing in, a big long response to your query. Enter a number, I'll print out the square root, right? On some systems, they can also overflow beyond that part of your memory and start getting into the code. And they can change what the code is that's being executed. So there's lots of exploits possible with this. And certainly if you're doing something that involves any kind of security, like giving someone access to their account, right? You've got a flag that says, is this person authorized or not? Well, you just have to find where that flag is in memory and change it to a true, and now you got access. But there's all kinds of things you can do.
Does this server have built-in stuff? Because when I was working on sticks.c, it said attempted buffer overflow because I made a string that was too small.
Oh, okay.
So I think it actually detected
Was it the compiler or was it when you were running it?
when I was running it.
Oh, okay. Yeah, so there's different switches you can put on GCC, and I think by default it's set up to detect when a buffer is overrun. That's not always the case. It depends on your installation. And that's usually there just to kind of help you, because usually a buffer overrun means you've got a problem. You forgot to check some condition, or you were off by 1 in your edge case or something like that. So we avoid gets in general. I only use it when nobody's looking. All right, fgets does what you need. All right, it just takes a couple of extra arguments. All right, so that's how we can get input into a variable from the user. Let's use this to play with scanf. I usually like to declare variables up top. All right, so let's do scanf on the string as a %d and save it into our integer called value. And result will tell us how many things were processed. Okay, so if result equals 1, and we'll say good, you entered the integer, and we'll show you the value of it. Otherwise, I'll print out an error message and say %s is not a valid integer. And I'll print out the value of the string that was typed in. All right, so let's run this. So enter something, 45. Good, you entered the integer 45. That's great. Go, haha is not a valid integer. And it's still got the new line at the end. So it came out on a new line. Go and just hit an enter. Enter with nothing after it, just a new line is not a valid integer. Go 0x34. Good, you entered the integer 0. Well, so scanf does something in particular. Scanf starts at the beginning of the string, and if we say, let's scan for a %d, which is an integer, it will start at the beginning of the string and it will say, is this first character part of an integer? If it's not, gives up. If it is, it'll say, okay, that's part of an integer. How about the second character? If that's also part of an integer, it'll keep going. If it gets to a point where something's not a part of an integer, but it's found an integer so far, it'll say, okay, yeah, I scanned an integer, here's the value. And it'll return a 1. Even if there's other stuff after that. Okay, because you might be planning to put in some other stuff later on. So scanf starts at the beginning of a string. If from that point forward it can match whatever you're scanning for, an integer, a 2 int, a double, whatever, right? Even if at some point it finds something that's not part of that, it will go ahead and say, yes, I succeeded in scanning and converting. It'll save your integer value and return a 1. So this is one glitch in our code, right? And it's a bug or a feature depending how you look at it. It's actually a feature because it means that it'll only scan up through the integer, and then we can scan the next stuff in our input with some other format. But we want our ODP to notice that there was, something entered that was not a single integer, or 67, haha. So here's a trick, okay? This gets the important flash screen on it. So here's a trick we can use. So let's make a temporary array, and let's scan a %d followed by a %s. So %s matches any string up to white space, and by default scanf stops strings when you get to a white space. So if I say a space b space c, %s would match an a. If I say hello space bye, %s will match hello. If I say %s, that would match hello and then bye. So I'm going to scan %d, which will be an integer, and I'm going to save that into value. And then I'm going to ask to scan any string after that, any non-empty string, and save that in temp. And I don't have an ampersand in front of temp because temp is already the address of our string because it's an array. So arrays, you don't put the ampersand. And result should still be equal to 1. If I type 45 followed by anything other than white space, that anything that I typed in will scan as a %s, get stored in temp, and result will be equal to 2. So let's make our message. So let's check the value from scanf. If it returns 1, it means it found an integer. It did not find anything after that. That's exactly what we want. It says, good, you entered an integer. If the result is 2, we're going to say you entered some extra stuff, which we would, in the ODP say this is not a valid integer. Otherwise, we're going to say the first thing that you typed in was not a valid integer. So type nothing, it's not a valid integer. Type some text, it's not a valid integer. Type a number, that is a valid integer. Type a number followed by anything that's not part of an integer. Oh, yeah, but it was right. Oh, wait a minute. It's messing with me, man. All right, I forgot to compile. All right, type in an integer followed by anything after it, and it'll say, you entered some extra stuff. So if I type in 2.5, it says you entered some extra stuff. If I type in 25 and then a space and something after it, you enter some extra stuff. So the only way that this is going to successfully parse is if I just type in an integer. So in PA2, when you want to make sure that they've typed in exactly an integer, right, you can do something like this, scan with a %d and a %s, and make sure it only returns 1, not 2. Does that make sense? I'll post this on the server and you can mess around with it. Yeah.
What did you say about the space? Like by default, if it's space, it means two.
So %s will match everything up to a space, a white space. So let me do this. Let's say you entered extra stuff. Let's print out this extra stuff temp. So if you entered, if it returned 2, we'll print out the stuff that matched this %s that we saved into temp. So if I try 2.5, it says you entered extra stuff, which was 0.5. If I say 2, 3, 4, 5, it's just going to say you entered extra stuff 3. Okay, when I scanned with scanf, the %d matched 2, the %s matched 3. If I did another %s, that would match 4, and if I did another one, that would match 5. But we don't really care if there's more than one thing after the number. We just care is there anything after the number. So we can just look at a single %s, and if it finds a string, that's enough to say you didn't just enter an integer. You put some extra stuff in.
I was wondering, is there a way to tell it to use a character other than white space as like the end of?
I think there is. I don't know how.
Okay.
The man page should probably tell you. But I don't know off the top of my head how to do that. I think if I had to do it and I was time crunched, I would just take your string and I'd convert the spaces to whatever delimiter, or convert whatever delimiter I wanted and go from that. But yeah, there should be a way. Scanf is a cool function to think about. To think about like trying to write that yourself. Trying to convert a string into, say, an integer is a good exercise in string processing. Trying to convert a string into a double precision number is a fairly hairy proposition because there's so many different ways that a double can represent. It could start with a plus or a minus or nothing. It could start with a period. It could start with an integer followed by a period, or a minus sign followed by an integer followed by a period, and could have an E in there for scientific notation. And scanf is wonderful. It just does all this stuff for us. All right, so that's on the server, on the code samples. And you can use this for your ODP, right, for parsing your input. And you can use it for your stick matching game. Okay, let me talk about scanf versus scanf. And let me tell you why I don't ever want you to use scanf. Okay, I want you to use scanf with fgets. Scanf combines those two things together. Scanf does like scanf, but instead of converting a string, it reads directly from standard in and converts. And I'm going to suggest that you never want to use scanf because you want to separate the input and the parsing, the interpretation of the input, into two separate steps. For a few reasons. One, sometimes we don't know how to interpret the input until we start trying to interpret it. We might take a piece of input and we might first say, is this an integer? And if it's not, then we might say, is it a double precision number? And if it's not, then we might say, is it one of these strings? Okay, we'll do this a lot in programs in 222. We'll parse input a lot of different ways. If you use scanf, it reads from standard in, and it kind of uses up the stuff that it matches. And so you might try to read from standard in and find an integer, but then find out it's not the kind of integer you expected. So it might be part of a string that started with an integer. You can't go back and rescan. But let me show you the most common problem with scanf. So let's prompt the user to enter an integer. Alright, so value is an integer. We'll prompt the user, enter an integer please, and we'll do a scanf with %d and save the result in value, and we'll check the return value. And if the return value is equal to 1, we'll kick out of the while loop and say thank you, and we'll show the value you entered. If the return value is not 1, if they did not type an integer, we're going to say, oops, that didn't work, please try again. We'll go back and we'll call scanf again. And hopefully at some point the user will type in an integer, and scanf will return a 1, and we'll say good, thank you. So that's a reasonable thing to want to do. So let's run this, and let's put in an integer, 42. Thank you, you entered 42, no problem. Okay, let's run this, and let's put in something that's not an integer, like haha. And it's going crazy. Stop. Thank you. You gotta wave your hands. So what's going on here, right? Scanf, like sscanf, basically reads until it can't read anymore according to what you're trying to convert. So here's the deal. If my input is 42 and I'm saying scanf %d, it looks at the first character I type, is that part of an int? Yes. Looks at the second character, is that part of an int? Yes. Looks at the next character, it's actually a new line. That's the end of my input. It converts a 42 and returns that, and scanf returns a value of 1. That works great. If my input is haha, scanf looks at the h. Is that part of an integer? No. It stops right there. It does not ingest the h because it's not part of an integer, and it returns 0. The next time I call scanf, it looks at my input buffer, and there's that h still sitting there. That's not part of an integer. It returns 0. Call scanf again, looks at the input buffer. The h is still sitting there because nothing has absorbed it yet. Right? And as many times as I call scanf, it's just going to keep seeing that character that I typed. I would need to do something like, I don't know, somehow absorb that, do another scanf with a %c maybe, and do something like that. But then if they typed in like h2, that would count as an integer the next time. So I need to maybe absorb input with %c till I get to a new line, all kinds of weird stuff. Okay, and there's no reason for that. There's no need for that if you do fgets, which says read everything up to a new line, throw it into the string, and then just start using scanf on that string. And you can scan it 100 different times, 100 different ways, and it's always just a string, right? It's got nothing to do with the input part. Does that make some sense? Scanf also has potential if you use a %s to do a buffer overrun, because there's nothing that says, you know, how much we're going to put into that buffer. Scanf, you're scanning from a string. If your string is 1,000 characters, it's not going to find more than 1,000 characters in there to store into a string. But if you scanf with a %s, it's kind of like using gets. If there's 1,000,000 characters on your input string without a space, it'll throw those into your string, even if your string only holds 10 characters. Yeah?
Can you explain why a star had H and not move?
Because scanf only moves when it successfully converts something from the input. If I'm scanning with a %d, that's not part of an integer, it's going to leave it in the input stream.
So even you just write one scanf, but if it's not integer, it will stop here and keep doing scan.
If it's just one scanf, it'll just try it once. But the next time I call scanf, it's going to still be looking at that H. Right? So if I just use scanf once, it's not going to loop. But, you know, the hope of code like this is, you know, what we wanted to do is let you try a different number, right? But scanf won't do that until it's read everything and processed everything on the current input line. So this book that I posted, chapter 2, is basically all about gets and fgets and scanf, and it spells out the issues here in 4 pages, so it's pretty succinct. So that's over on the server also. All right, questions? Well, we got 5 minutes to talk about VI. So let's play with VI for 5 minutes. We were talking about how to remove text. We talked about adding text, right? And I said you can use a period to repeat your last command. So let's talk about removing text. So if you want to delete a character, just hit an X. X means delete. If I want to delete 10 characters, I can say 10x. If I want to repeat my last command, in this case delete 10 characters, I can just hit a period. And delete only works on your current line, and if I'm at the end of the line and I try to delete, it actually deletes the character under the cursor and it moves back. But unlike some of these other commands like W for moving forward a word, X will stay on one line. DW will delete a word. So if you want to take out a bunch of text, you can just DW, and that'll go one word at a time. So a U will undo your last command. So U will undo the delete of the O on echo, and another U will undo the undo. If I want to undo everything that I did on a line, I can hit an uppercase U. Oh, but that was, yeah, so I can delete a bunch of stuff on here. If I hit an uppercase U, that'll undo all the changes on that line. But only while you're on that line. If you move off that line and come back, you can't do a big U anymore. But the quick undo is just a U. And on some installations of VI, there's multiple levels of undo. On some, there's not. I think on the server, hitting U multiple times undoes multiple times. You can say :redo to redo a change. Or just never make a mistake. That's the easier way. So DW will delete a word. If you want to delete everything from your current point to the end of a line, Shift D. So that wipes out everything from where you are to the end of the line. And then DD, two small d's in a row, deletes the entire line. No matter where you are in that line, you can be in the middle of it, DD deletes the line. And so if I want to start deleting, this whole loop, I can just say DD and hit period a few times. Or if I know I want to delete these 6 lines, I can say 6DD, and it deletes 6 lines. All right, anytime you delete something, a character, a line, a set of lines, it goes into a paste buffer. So I just deleted 6 lines. If I wanted to paste that somewhere in my code, like say down here at the bottom, I can just hit a P, and it'll paste that after my cursor position. If I were to do a Shift P, that'll paste before my cursor position, which is mainly useful at the beginning of a line or file. So I want to move these 4 lines of comments. I can say 4DD, 1G, and then an uppercase P. And now that's back in the beginning of my file. And if you want to delete some stuff, if you want to copy some stuff without actually deleting it, you've got a few options. If I wanted to take these 5 lines, I could do 5DD and then undo that and then paste it. Or I could say 5 and an uppercase Y for yank, and it'll yank 5 lines into the paste buffer. So either delete it and then undo the delete, or just do an uppercase Y, and that puts it in the paste buffer. Yeah?
So I was playing around with like the yanking and stuff. And
Yeah.
I think that only works when you're within VI. Like it doesn't copy it to like the clipboard if you wanted to like.
No, this is just inside VI.
Is there something that does copy it to the clipboard?
There's probably some plugin you can use somewhere, but on most systems, right, that's on my clipboard now.
Oh.
All you got to do is highlight it. And it depends what system you're using. If you're using PuTTY, you can set up under the options what the mouse should do. And you can set it up so selecting copies, and I usually set up middle mouse button as a paste, but that'll put it straight on there. All right, so we'll continue this tomorrow. Let me leave you one more. A tilde changes case. So if I just lean on tilde, I can like change the case of everything on this line. Or I could do, 100 tilde and just change it all. That's a useful one once in a while. All right, so we'll continue with this tomorrow.